And so reference angles, if we're in quadrant 1 and we have the angle like this, some given angle t is just a reference angle. But if we're in quadrant 2, and so our angle t is in quadrant 2, then the reference angle is the shortest distance from the x-axis, so that would be t prime is over here. If we're in quadrant 3, so angle t goes around like that, the reference angle is again the shortest distance from the x-axis. So this would just be our reference angle t prime. And then finally, quadrant 4, if our angle t goes all the way out here, then the reference angle, the shortest distance, is here. So to calculate a reference angle, t prime, if it's quadrant 1, it's just t. But quadrant 2, if you look here, t and t prime add up to be this full length, which is either pi or 180, depending on what units. So t prime is going to be pi minus t, or 360 degrees, 180 degrees minus t. In quadrant 3, we are past the horizontal over here, and so we would, to figure out what this is we would subtract from that. So t prime, our reference angle, is going to be our angle t minus pi, or t minus 180 degrees. And then in quadrant 4, we are this much, so our angle t plus our reference angle t prime make a full circle. Therefore, solving for t prime, we would get that t prime is either 2 pi minus t, or t prime is 360 degrees minus t. So given an angle t, to calculate the reference angle t prime, and this is going to be in radians, if t is greater than 2 pi, or if t is negative, so if we're greater than one circle, then we add or subtract multiples of 2 pi to obtain a coterminal angle between 0 and 2 pi. Then find the reference angle. And then in degrees, basically it's the same thing. If t is greater than 360 degrees, or t is less than 0, degrees. Then you add or subtract multiples of 360 degrees until we get something that's in that between 0 and 360. So let's go back up for a second. What we did up here was we calculated the reference angle given some angle t. Okay, so we found what t prime was. We could instead calculate the angle t given a reference angle and its quadrant. So basically what we want to do is solve for t given t prime. So if we say that our reference angle was t prime and we're in quadrant 1, then we'll have the same thing. T is just t prime. If we're given t and we're in quadrant 2, so we're going to convert this, solving for t, we end up with t is pi minus t prime, or t is 180 degrees minus t prime. If we're given the reference angle and we say we're in quadrant 3, then we'll solve for t here, and we have that t is pi plus t prime. So we can't just interchange it, we're just solving for t. So we don't switch t and t prime, but we solve for t. And t is 180 degrees plus t prime. And finally, if we're in quadrant 4, then what we get is t is 2 pi minus t prime, and then t is 360 degrees minus t prime. Now, for radians only, if the reference angle, again in radians, is of the form t prime is a times some pi over b, then the angle in standard position, t, can be given as the following. So here are our quadrants. So in quadrant 1, t is just t prime. And so t prime was that a pi over b. In quadrant 2, what it is you take your denominator minus your numerator, a minus b, pi over b. So quadrant 2, we're there. Quadrant 3, you add your denominator plus your numerator, and that's going to be b plus a pi over b. And then in quadrant 4, we get that we're twice the denominator minus the numerator times pi over b. All right, so let's say, for example, if we have a reference angle, t prime is pi over 6. What is this in the third quadrant? In quadrant 3. So from before, we had quadrant 3, we know that t is going to be pi plus our t prime, pi plus pi over 6. Adding this together, so pi becomes 6 pi over 6 plus pi over 6, so we get 7 pi over 6. But using this second method that we just described right here, you could also have written t as our denominator, which is 6, plus our numerator, which is this, it's really 1, pi is 1 pi, times pi over 6. So we get 7 pi over 6.